Okay, so if we make this correction, everything follows qualitatively, and everything makes sense, okay? This term approaches zero. But if you divide by the 5.4, this becomes 0.021, okay? Now, if you multiply by 5.4, it doesn't. So something's messed up, but the 5.4 and this is going to end up giving you a 0.021,
Right.
which will be your asymptotic value of the amount of solute.
Right, because that
Same as it
relates
was
back to your
before.
limiting factor.
I'm sorry?
That's what's relating back to your limiting concentration, right?
Right,
Okay.
right. Because limited concentration, as we saw pretty quickly, like in this case, is certainly going to be the same, right?
Right.
And this case is just like an oscillatory case of this, but with a little greater flow rate.
Right.
So it's going to go down a little quicker. And that 5.4, whatever happens with that 5.4 is going to appear in all these terms, okay, because it appears in the whole right-hand side. Except it doesn't occur here. Yeah, it works out. And it's really an easy equation. Now, the thing I want to be sure we understand is that what we've done here is no different than what we always do, okay? We do our rate in, we do our rate out, and we take what we get. There's our equation. Maybe you can integrate this, maybe you can't. Maybe this term also involves Q, in which case it gets kind of nasty, okay? Well, I won't go into detail, but you can have all kinds of things. What if you're pumping stuff in and back pumping it? Or what if you're pumping your 2.1% into one vat and that into another? You get a more complicated expression, okay?
Right.
Depending on the exact conditions of inflow, outflow, and what you're doing. So there are all kinds of things. It just occurred to me, I could say, okay, you're pumping in, but sometimes you pump back, okay? And then what happens? The equation can get as complicated as I'd want to make it, but I didn't ask you anything too complicated here. I also only ask you on this, at least this version of the practice test, to write the equation. I didn't ask you to solve it,
Right.
okay? But solution's interesting, especially since I can't get it right, okay? So
But basically, just remember R in, R out, and the net rate, and you'll
that's
be
it.
on the
I mean, it's R in, R out, net rate.
Okay.
Q is the amount of solute. That's the variable that you use in your equation,
Right.
okay?
I think I was just trying to make it too complicated.
And in other equations, of course, maybe your tank isn't full at the beginning.
Right. And that's
Well,
when
then
we
your volume will
factor our-
become a function of T,
Right.
okay?
That's when we factor in our V.
Which can complicate things a bit, often not badly, okay? Or maybe you have an outflow that exceeds your inflow, okay? So what happens to your concentration? What's the limiting value of concentration as the volume approaches zero? So there are all kinds of questions that can be asked, but if you keep track of this and understand that V might be a function of T, okay? The Q is a function of T,
Right.
then you can write it out and deal with it as best you can. Best case, it's separable.
Right.
Often it's linear, non-homogeneous. And if it's not one of those two, you probably won't be able to solve it.
Okay.
I could contrive something of that nature, but it probably wouldn't naturally occur.
Right.
Okay?
Okay.